Now I am talking about modified Euler methods or improved Euler's methods or Hume's method. So modified Euler method or improved Euler method or Hume's method approximation is given by the formula yn plus 1 is equal to yn plus h by 2 into f of xn plus yn plus f of xn plus 1 then yn plus 1, or in other way we can write. So first calculate k1 is equal to h by h into f of xn yn, then x2 hf xn plus h yn plus k1, and then yn plus 1 is equal to yn k1 plus k2 by 2. So we can use this formula or this formula, so but this formula is easy than this. So first we have to find out k1, then k2, and then after that we have to calculate yn plus 1. Now here I am taking one example. So consider the first OD, dy by dx is equal to x square plus y, and the condition is given y is equal to 0 is equal to 1, means at x is equal to 0, y is equal to 1. That is the condition is given. Now using modify Euler method, approximate the solution of OD and finds y at x is equal to 1. Now the modified Euler method, also known as improved Euler method or Hume's method, is an enhance of the basic Euler method. It involves performing two evaluation of the derivative with a single step to obtain more accurate approximation. So let's divide the interval 0x into smaller sub interval with a step size h, and then we can calculate that modified Euler method. So now modified Euler method approximation is given. We know that k1 is h f xn and yn, and x2 is equal to h f xn plus h yn plus k1 yn plus 1 yn plus k1 and k2 by 2. Now let's compute the numerical approximation, the solution using modified Euler method. So now here x is equal to 0.1 and step size is equal to h is equal to 0.1 and y0 is 1 at x0 is equal to 1. Now first we have to calculate k1. So k1 is, and we know dy by dx is equal to x square plus y, so that is nothing but f of x y. Now k1 h f x0 y0, so h is 0.1 and x0 is equal to 0 and y0 is equal to 1. So if we do the calculation, we will get that is 0.1, k1 is 0.1. So now we can compute k2 is equal to hf x0 plus h y0 plus k1, so that is h is equal to 0.1 and x0 plus h0 plus 0.1 that whole square, and then y0 plus k1 means 1 plus 0.1. okay, so 0.1, so that is k1. Now if we do the calculation, we will get 0.121. Now y1 is equal to y0 plus k1 plus k2 by 2, then y0 is 1 and k1 is 0.1 and 0.121 by 2. Now ultimately 1.0605, so y1. So ultimately y at 0.1, y at 0.1, that value is 1.0605. So that is modified Euler method. Now if we can proceed further. Okay, means if that depending on the x value, we can take the step size and we can do the calculation. That's about modified Euler method.